morning, madam. My name is Ellie Erika Nanaster. My matrix number is 33DPE1NF2051. Okay, now we go to the oxidation. Okay, oxidation is the loss of electrons during a reaction by a molecule, atom, or ion. Oxidation occurs when the oxidation state of a molecule, atom, or ion is increased. The opposite process is called reduction, which occurs when there is a gain of electrons or the oxidation state of an atom, molecule, or ion decrease. Okay, next, I will talk about the function of bubble column in reactor. Okay, bubble column is a device in which gas in the form of bubble come in contact with the liquid. Okay, now the purpose may be simply to mix the two phases of substance are transferred from one phase to another when the gaseous reactant are dissolved in liquid or when liquid reactants products are stripped.
Good morning, madam. My name is Vaishwini Srimurthy. I'm from DPE 4. My matrix ID is 33 DPE 19F 2052, and today I am going to talk about the properties of ethylene and the properties of acetaldehyde. Ethylene, the IUPAC name ethene, is a hydrocarbon which has the formula C2H4 or H2C equals to CH2. Ethylene is a colorless gas at room temperature. Its melting point is negative 169 degrees Celsius. Its boiling point is negative 104 degrees Celsius. It has a slightly sweet smell. It is flammable and it is non-polar molecule. Ethylene is soluble in non-polar solvents and insoluble in polar solvents like water. Ethylene is reactive because the active site is the double bond. Now I'm going to talk about the properties of acetaldehyde. Ethanol, the common name is acetaldehyde, is an organic compound with the formula CH3CHO. It is one of the most important aldehydes occurring widely in nature, and it is being produced in a large scale in industry. Acetaldehyde occurs naturally in bread, coffee, and ripe fruit. The molecular weight of acetaldehyde is 44.05 gram per mole. Its density is 0.784 gram. Its boiling point is 20.2 degrees Celsius. Its melting point is negative 123.5 degrees Celsius. Acetaldehyde is colorless. Acetaldehyde has a pungent odor and it is soluble in water, ethanol, and benzene. Thank you.
Okay, this is the schematic diagram for oxidation of ethylene to acetaldehyde. Okay, feed stream F1 mainly containing ethane, and a trace amount of acetylene enters into the first heat exchanger E1 to heat the feed with the reactor outlet stream. Consequently, the hydrogen is injected to the feed stream and is heated in the second heat exchanger E2 to reach the reactor inlet temperature. The hydrogen stream F2 contains 1% carbon monoxide to increase the selectivity and surface coverage ratio of acetylene to ethylene. Okay, the reactor product stream is cooled down in 3 stages in E1, E3, and E4. Afterwards, it is sent to a flash drum, D1. The liquid flow from the bottom of the drum is forwarded to the juxtaposed unit while the vapor phase is sent to the distillation tower to separate ethylene from ethane. Okay, the vapor phase is ramified into 3 streams and each is fed to a specified tray of the water. The first stream, which comes from a juxtaposed unit mainly containing ethylene, is introduced to a flash drum D2 to separate the ethylene from the other lighter products such as methane. Okay, the bottom flow of D2 or S2 is fed to the first tray of the distillation tower. The final product is taken from the ninth tray, where the ethylene concentration is maximal. Okay, next is the function of each component of the schematic diagram. First is heat exchanger E1. It's to heat the feed with the reactor outlet stream. Okay, second is heat exchanger E2 to reach the reactor inlet temperature. The reactor product stream is cooled down in 3 stages in E1, E3 and E4. Okay, next is flash drum. The liquid flow from the bottom of the drum is forwarded to the juxtaposed unit. Okay, next is the distillation tower to separate ethylene from ethane. Now, next is flash drum to separate the ethylene from the other lighter products such as methane. The last one is the bottom flow of D2 or S2 is fed to the first tray of the distillation tower.
Good morning, I'm Ishani Bhubalan from DPE4. My metric number is 33DPE19 F2015. Today I'm going to explain about process of oxidation of ethylene. For the process, we have the Walker process. They name after the chemical companies of the same name because they refer to the oxidation of ethylene to ethylene in the presence of palladium chloride as the catalyst. This chemical reaction was one of the first homogeneous catalysts with organopalladium chemistry applied on an industrial scale. Moreover, a process for a manufacture of ethanol by the air oxidation of ethane. A mixture of air and ethane in bubble through a solution contain palladium chloride and copper chloride. The PD2 plus ion from a complex with the ethane in which the ion is bound to the pi electron in the C bond. This decreases the electric density in the bond, making the attack by water molecules. The complex form breaks down to the ethanol and palladium metal, and the Cu2 plus iron oxide, the palladium pack to PD2 being reduced to iron in the process. The air present oxidize Cu back to the Cu2 plus. Thus, the copper and palladium ion effectively act as a catalyst in the process, which is now the main source of ethanol by future oxidation and ethanoic acid. It can also be applied to other alkenes, which is they called after Alexander von Walker, which is happened in 1946 to 1922. For the reaction mechanism for the industrial Walker process, which is olefin oxidation via palladium chloride, has receiving significant attention for the several decades. Aspects of the mechanism are still debated. Thank you.